So we're going to finish up talking about photosynthesis today. And we've talked so far about the light reactions that was in the last video. And we saw there that you take electrons from water and you use light to heat to raise those electrons up in energy level. And then when you do that, the electrons are moved from carrier to carrier and the energy is lost, and that energy is used to pump hydrogens in here. So you get a bunch of hydrogens here in here, and when they go down their gradient from a high concentration to a low, that energy is used to move this enzyme, change the enzyme shape a little bit, and make ATP. So if you look at the light reactions, you start out with water. Oxygen is a byproduct, and you use the light to raise up the electrons from water to another higher energy level. And with that, you make the carriers NADPH and you make some ATP. So the ATP stores energy, and the NADPH is taking those electrons and hydrogens. And so what we're going to do now is look at the light-independent reactions, or the Calvin cycle. So that's our next step. They're called the light-independent reactions, or the Calvin cycle, or the calvin-benson cycle. And so ATP and NADPH from the light reactions are used as energy. So if you remember that total equation for photosynthesis, you have carbon dioxide plus water, and that makes
Glucose C6H12O6.
And what's the byproduct?
6O2. Just O2, sorry.
Yep. No, yeah, you're right. Let's put the sixes in. And this is high energy, so where did you get your energy over here?
The sunlight.
Excellent. And so far, for the light reactions, what are the reactants that we used for the light reactions? Do you know?
Sorry, what was the question?
We're about to start the light independent reactions, but for the light reactions, can you tell me what we've used so far?
Oh, you've used 6 carbon dioxide, 6 water, and some light.
You haven't used any carbon dioxide yet. Nope.
So
just with the light reactions.
I don't remember.
That's okay. You used light. Do you know where you got your electrons?
From the water.
Good. And you made a couple of intermediates. What does an intermediate mean?
It means it's used in the middle.
Yeah, so it's not a reactant, it's not a product, it's something that you make in the middle. It's like the product of the beginning, but the reactant of the end. Do you remember the reactants? There's two, I mean the intermediates, there's two of them.
NADPH.
Good.
And FADH?
Nope, that's for cellular respiration, but there's another one.
ADP? ATP?
No, ATP. So this is some energy that you changed light energy into chemical energy here when you did that chemiosmosis thing from the light reactions. And then you have your electrons and your hydrogens here. So these are something called the intermediates. And then you have a byproduct, a waste product, which is the oxygen. So it's good that they make that because we need it. But it is just a waste product for them at this point. So the stuff that I have not circled, carbon dioxide and the glucose, is what you need, is what you're going to be doing in the light-independent reactions, the reactions that do not need light. And so that's where we are. So you're going to get carbon dioxide, and this is carbon with a couple of oxygens, no hydrogens.
I have a question. Yeah. Aren't there some more water, but equation is the net gain?
Right, that's right.
Okay.
Yeah. So what you're going to do is put hydrogens on here from here, and here they are. So far, so good?
Mm-hmm.
Okay. So you take high energy ATP and you do something called carbon fixation, which means you're going to put a whole bunch of carbons, 6 of them, together here. And you're going to get your hydrogens from NADPH, and of course the electrons that go with the hydrogens will go on there too. So atmospheric carbon dioxide is used to make sugars like glucose and fructose, and that's called carbon fixation because you're taking carbon and you're sticking it all together, fixing it into this molecule. So if any of you are artists and you make a drawing and it's a charcoal drawing and you have, your trees and your sunshine, whatever you're making, sometimes you'll spray it with a fixative to make it set, to keep it there, and that's how I think of carbon fixation. You're taking these CO2s and you're sticking them together, setting them in place. So my students, you need to add this to your notes unless I fixed it. So unless this is sometime in the future from 2014, you probably have to add this to your notes. So here's what the light-independent reactions do. It combines carbon dioxide, which is this, carbon with two O's, with the hydrogen ions, which are these, and the electrons, which are these, that the delivery boy carries. So you've got these carbon dioxides, which have low energy. You're getting your high energy from the electrons and the hydrogens from your delivery boy. Plus, you're going to get ATP from those light reactions. So you're going to pause this and write in it, or the light independent reactions combine carbon dioxide with hydrogen ions and electrons from the NADPH and the energy from ATP to dun 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 make sugar or glucose, you can write. And so if you look at this, it's got carbon and oxygen. You got it. You've got carbon and oxygen just like you have here, but now you've got hydrogens combined onto there. And so you have a high energy molecule and you made it from ATP. David, how come we just don't finish with ATP? Why bother making the glucose?
Because ATP will decay.
Yeah,
If you just leave it around.
exactly. It's not a good energy storage molecule. Very good.
It's a good energy source. It'll just like deteriorate really quick.
Right. So you use it for anything that the cell needs right away, but it doesn't store energy very well. Good. So these 6 carbon sugars are made during the light independent reactions or
light dependent. Wait, what do you want me to?
Light independent reactions or the, do you know the name of it? It's named after the guy.
The Calvin-benson cycle.
Very good. Or just the Calvin cycle if you want. Either one's right. And this occurs where? Do you know in the chloroplast?
Thylakoids.
Nope, the thylakoids are the light reactions.
Oh, sorry. It just occurs in the stroma.
Yep, the goop. It occurs in the stroma, which is the goop inside the chloroplast. It's like cytoplasm, except it's in the chloroplast, not just in the cell. And so here's a summary of what's happened. The light reactions used the electrons from water, bumped them up to higher energy levels with light, which allowed you to make ATP and NADPH, this with that whole electron transport thing. You have these 2 energy molecules. You take this low energy carbon dioxide plus these. The electrons and the hydrogens are put onto here with the energy from the ATP, and you make sugar, yay. And so that's what this looks like. So you've got this, let's see, 1, 2, 3, 4, 5 carbon thing you put together with that 1 carbon thing, and you make, well, actually, the 5 plus the 1 gives you a 6. 1, 2, 3, 4, 5, 6. There's a 6 carbon intermediate. It's not very stable. It breaks down right away to 2 of these. And then you use some ATP, and you put another P on here, and then you give it some electrons and some hydrogens, and you make this. And some of those are used to come out here and to make sugar. Some of them, though, are used to just regenerate what you had before. And so you need to regenerate this to be able to continue the cycle and do more and more and more.
So you can't just start off from nothing?
You can't just start it from nothing. Excellent. That's right.
So do scientists know how the first one started then?
You know, the beginning of life is a really interesting question.
So the answer is scientists don't know.
Scientists probably don't really know.
Okay.
Yep. So here's another thing. You've got this 3 carbon thing, and you actually need 3 carbon dioxides in order to make that. But in order to make this, you need 2 of those to make glucose, so you really end up needing 6 carbon dioxides altogether to do that. And it goes around a whole bunch of times. But each of these carbons originally had come from some carbon dioxide added one at a time to this stuff. So 6 turns of the Calvin cycle are required to make 1 molecule of glucose. And carbon dioxide molecules enter the cycle to form several intermediate compounds. So you don't have to memorize all these different things. You just have to get the idea that you add carbon dioxides plus energy from ATP plus electrons, high energy electrons and hydrogens to this carbon thing in order to make your glucose. And so you need ATP energy and you need NADPH, which has the electrons and the hydrogens, and you use those for energy to make glucose. And then the other idea is that you make this molecule to regenerate the whole thing again, to regenerate the Calvin cycle. So you can't just stop here. You need to make this thing to keep going again. Factors affecting the rate of photosynthesis. David, what are the things that farmers worry about when they grow plants?
Water, a drought.
The amount of water, excellent. Anything else?
Well, farmers don't really worry about the amount of sunlight, but
that's important. You got it. So the amount of available light is another super important thing. Anything else?
Well, the pH level, but that
That's
wouldn't really,
true.
the farmers don't really have to worry about that, though, do
Oh,
they?
I don't know. Maybe they do, but
Well,
I don't know.
mm,
Yeah, maybe they do the pH of the soil. But that's not one of the ones I'm looking for. What do
mm,
you think? At the end of the year, our tomatoes stop growing. How come? What happens?
temperature.
Temperature. So we get a frost, and our tomatoes are gone for the fall. And then there's one of, ooh, I didn't mean for that to come in. So here's another one. Farmers never worry about the amount of carbon dioxide, yet it's still a reactant in photosynthesis. And so carbon dioxide levels are rising in the atmosphere. How come?
Because of all the fossil fuels we're burning.
Beautiful. And so that
Well, and
might
the
have,
forest that we're chopping down, but that's
it's true.
just,
No, no, no,
it's
that's
more
true.
slowing the rate of getting rid of it, which is,
That's true too, which is still raising the levels.
yeah,
So anyway, this extra CO2 around might have an effect on photosynthesis as well.
but it would probably speed it up.
Yes. And so these are the four factors that I want you to know. There's also stuff like nitrogen. Nitrogen does not directly affect photosynthesis, but if you don't have enough nitrogen, then the plants won't be able to build some of their parts, and so then they won't be able to grow. And if they won't grow, then they won't be able to do as much photosynthesis, which could decrease the amount of carbon dioxide that they could take out of the atmosphere. And that is the end of our story. Goodbye, light dependent reactions? No, these were the light independent
Oh,
because they don't depend on light.
sorry.
No, that was me. I got that wrong.
Okay.
Okay, have a great day.
Okay,
Bye.
bye.